Integration 0 to pi by 4, 2 tan cube x dx, 2 outside, tan square x into tan x dx, 0 to pi by 4, 2 outside, tan square x is x square x minus 1 by fundamental identity, 0 to pi by 4, multiply tan with both, so x square x into tan x minus tan x, dx, 0 to pi by 4, I1 and I2. Let this be I, equation number 1. Solving I2 first, 0 to pi by 4, log mod sec x, 0 to pi by 4, box minus box, log mod sec pi by 4, log mod sec 0, sec 45 is 1 upon cos 45. So it's the reciprocal of cos 45. So that's root 2. Sec 0 is 1 and log 1 is 0. So the answer of I2 is log root 2. We'll take I1, 0 to pi by 4, sec square x into tan x. Put tan x is equal to t. Method of substitution, the derivative of tan is present in the problem, that is sec square x, which is there in the numerator. So sec square x dx I will shift on the left hand side, equal to dt. The value of t is tan x when x is equal to 0, tan 0 is 0. When x is equal to 1, t is equal to 1. So I1, 0 to 1, t dt, because tan x is t, so sec square x dx will be dt. Okay. T square by 2, 0 to 1, box minus box. In place of t, put the upper limit. In place of t, in the second box, put the lower limit. Answer is half. Okay. Now from 1, I is equal to, there was 2 outside. I1 is half. I2 is log root 2. Okay. So you multiply 2 with both. 1 minus 2 log root 2. Now this 2, you can take it over here and make square for the value. So root 2 square will be 2. Next problem. Integration 0 to pi dx upon pi plus 3 cos x. Now see, whenever there is sine and cos term in the denominator, we have a specific type that's constant upon a sin x plus b cos x plus c. A, B, C are constants and they can be positive or negative. So out of this three, any two terms will be there or all three terms will be there. So method for such kind of problems is put tan x by 2 is equal to t. Put tan x by 2 equal to t. D by dx of tan x by 2. D by dx of t. X square x by 2 into d by dx of x by 2. Chain rule. Dt by dx. Okay. So there is no sec square x by 2 in the problem, in the question. So I just shift it on the left hand side. 2 will also go and sec square will go down. Dt. Now sec square x by 2 is 1 plus tan square x by 2. Identity. But then tan x by 2 is t. So this is going to be 1 plus t square. Okay. So dx is 2 upon 1 plus t square. Now in such type of problems, sin x is equal to 2 tan x by 2, 1 plus tan square x by 2. So this will be 2t upon 1 plus t square, and cos x is 1 minus tan square x by 2 upon 1 plus tan square x by 2, 1 minus t square upon 1 plus t square. So in our problem, there is only cos term. Okay, so replace dx by 2 upon 1 plus t square. Okay, 2 dt upon 1 plus t square. That's the value of dx. And this we wrote as 2 upon 1 plus t square dt, and cos x is 1 minus t square upon 1 plus t square. So 5 plus 3, 1 minus t square, 1 plus t square. We have to change the limit also. T is equal to tan x by 2. So when x is equal to 0, which is the current lower limit, tan 0 will be 0. And when x is equal to pi, so tan pi by 2, tan 90 is not defined. So this will be 0 to not defined. Okay. 2 dt, 1 plus t square. 5 down in the denominator, I'm taking LCM. So this got cancelled. 2 will go outside. Okay. So 2, 0 to infinity. Okay. And 5 plus 5t square minus 3 minus 3t square. 5 plus 5t square minus 3 minus 3t square. Let me check once again. Plus 3 minus 3t square. Okay. 2t square plus 8. Take 2 common. T square plus 4. So this is 1 upon t square plus 2 square dt. So that's 1 upon a tan inverse x by a is 2. Okay. X is t. So half outside. tan inverse t by 2, 0 to infinity, half box minus box, okay. So tan inverse in not defined upon 2 is not defined, and tan inverse of 0 upon 2 is 0. Tan inverse of not defined is 90 degrees. 90 degrees is pi by 2, and tan inverse of 0 is 0. Okay. So half into pi by 4 is pi by 4, which is the required answer. Integration 1 to 3 log x 1 plus x square dx log x 1 plus x square dx 1 to 3. This is u and this is v. Light logarithmic comes first before algebraic. Log x 1 plus x square the whole square 1 to 3 bigger integration d by dx of log x 1 plus x the whole square log x integration of 1 plus x the whole square. Uh, just a second. I think this should be minus 2, sorry. Okay. Yeah, so the integration of 1 plus x raised to minus 2 will be raised to minus 1 upon minus 1. Bigger integration. Okay, this is box bracket 1 to 3. This is 1 and 3. dy dx of log x is 1 upon x, and integration of 1 plus x the whole square. Okay. Okay. Now this minus and this minus will be plus 1 upon x 1 plus x. Right. Now this is partial fraction type 1. Degree of the numerator is 0. Degree of the denominator is 2. Degree is less. We can apply partial fractions. But then I'll use a shortcut for this problem. Okay. I'll not go into partial fraction. If it clicks, well and good. Otherwise, don't use this shortcut. So here it is going to be box minus box plus 1 to 3 1 plus x minus x. So I'm adding x and I'm subtracting x. Okay, if it clicks, well and good, otherwise don't use this. 1 plus 3 log 3, 1 plus 1 log 1. Okay, now this box bracket is going to be 0 because log 1 is 0, and this is going to be minus 4 log 3, and here I'm going to split. Okay, so there is plus and 1 plus x upon x into 1 plus x minus x upon x into 1 plus x dx. Okay, 1 upon x minus 1 upon 1 plus x minus 4 log 3 plus log modulus x upon log modulus of 1 plus x. I'm using integration of 1 upon x formula. Okay, upon dy dx of 1 upon x, 1 plus x is lat. So that's 1. 3 and 1. minus 4 log 3 plus log x upon log 1 plus x. Log a minus log b is log a upon b. Minus 4 log 3 plus box minus box 3 3 plus 1 1 1 plus 1. 3 by 5 minus log 1 by 2. Okay. Minus 4 log 3 plus log 3 by 5 divided by 1 by 2. Log a minus log b is log a divided by b. Okay. So minus 4 by 3 plus log 6 by 5. Okay. So just a second. I think this should be 4. Sorry. Okay. 3 plus 1 is 4. Sorry for that. So this will be cancelled. 2 ones are 2 twos are. So it's 3 by 2. Okay. Right. So yes. Now again, I'm going to split this minus 4 log 3. Now this is not really required, but then some proofs are there. Some same problem is asked in a form of a proof. Minus 4 log 3 plus log 3 minus log 2. Okay. Uh, yeah, again, I think, sorry for this. This should be minus 1. Okay. So, yeah, I forgot to write that minus 1. So that's what I was wondering. Okay, something somewhere I have left. Okay. So this will be 4 raised to minus 1 is minus 1 by 4. Okay. Just make this minus 1 by 4. Now minus 1 by 4 plus 1. So that is 1 minus 1 by 4 because log 3 is common over here. So 1 minus 1 by 4 is 3 by 4. So 3 by 4 log 3 minus log 2. That is your final answer. Okay. So they will ask you to prove this. Okay. Otherwise you can stop your solution over here. Minus 1 by 4 log 3 plus 3 log 2. Yeah. Next problem, integration of 3x upon 9x square minus 1. This is 2 and this is 1. Now I'm just observing the derivative of the denominator to be 18x. So we can easily make this 18x by multiplication and division by 6. 6 being a constant, we can keep it outside the integral. So it's multiplication and division by 6. Because we are making the numerator the derivative of the denominator. So 1 by 6, 1 and 2, 18x, 9x square minus 1. Okay, so this is f dash x and this is f of x. So 1 by 6 log mod f of x. Then you can do box minus box, but then while doing box minus box, do those things within this curly bracket. Okay, and then log a minus b is equal to log a upon b. So that I leave it up to you. One problem you can take for self-study, practice it. The derivative of the denominator is 6x raised to 5. So here also you need to multiply and divide by 6. Okay. We'll take some problems of method of substitution. 0 to 1, e raised to 2x, 1 plus e raised to 4x, 0 to 1, e raised to 2x. Now e raised to 4x, I'll just write it as e raised to 2x raised to 2. Okay, because if you square this, you will get e raised to 4x. Now the derivative of e raised to 2x is e raised to 2x, right? Along with the chain rule. So that term is present in the question. So put e raised to 2x as t, dy dx of e raised to 2x, dy dx of t, 2 e raised to 2x dt by dx. So e raised to 2x dx is equal to dt by 2. We require only e raised to 2x dx. So this will become dt by 2, and this 2 is due to the chain rule. Okay. So so dt by 2, 1 upon 1 plus t square. We'll change the limits also. T is equal to e raised to x, e raised to 2x, sorry. So when x is equal to 0 and when x is equal to 1, okay, t will be e raised to 2 into 1, that is e square, and t will be e into 2 raised to 0, e raised to 0, which is 1. Okay. So this will be e square and this is 1. I think it e raised to x is 0, no, sorry, x is 1. I have just made some mistakes over here, sorry. So yeah, so when t is equal to e raised to 2x, now you put x as 0. So e raised to 0 is 1 and put x as 1. So t will be e square. So 1 to e square. Okay. Half outside. 1 upon 1 plus t square, 1 to e square. Half tan inverse t, e square and 1. Half box minus box, tan inverse e square, tan inverse 1. Half tan inverse e square minus pi by 4. Okay. You can take that half inside and multiply with both the terms if you want. Okay. So I'll give you some problems to practice. Okay. I'll just discuss it right away. You can take it for self-study. I'll just give the hints also. 0 to pi by 2 cos x 1 plus sine square x. So put sin x is equal to t. Okay. So this will be t square. Okay. Sin x 1 plus cos square x. Cos x is equal to t. 0 to pi by 2 pi by 3 sec x tan x 1 plus sec square x. So put sec x is equal to t because the derivative of sec x is sec x tan x. So this will be t square. Okay. 0 to 1. So you are first going to express this in this way. Now put tan inverse x is equal to t. Okay. Because 1 upon 1 plus x square dx will turn out to be dt. Fine. Next one, next hint. Okay. 0 and e. Put log x is equal to t. That is the hint. Okay. Because this can be written in this manner. Cos log x into 1 upon x. T is equal to log x is equal to 0, and x is equal to e. So log e is 1. Log 0 is not defined. So I think we'll change the limit over here. Make 1 to 0, 1 to e. Okay. So this is log e, which is 1. Uh, 1 second. When x is 0, sorry. When x is 1, uh, just a second. If this is 1, I change the limit now. So the lower limit is 1. So log 1 is 0. So from 1 to e, it will change to 0 to 1. Okay. Yeah. One more end. Cos x 1 plus sin x 2 plus sin x. You can put sin x is equal to t. So once you do that, cos x dx will be turning out to be dt. And this is 1 plus t and this is 2 plus t. You multiply those two brackets in the denominator. Okay. And then you'll get a quadratic. There is 1 in the numerator. You can do half into coefficient of x. But then apply the integration formula very clearly. Okay. So this problem is also done. One more int. Practice all these problems. 0 to pi by 2. Sin x into cos x. 1 plus sin raised to 4x. 0 to pi by 2. Sin x into cos x. 1 plus sin square x the whole square. Okay. Now put sin square x is equal to t. That's the hint. Now trigonometric function with a power goes outside. Now you first treat this as x raised to n while differentiating. Okay. Yeah. Next hint. 0 to pi by 2 x square sin x cube dx. Put x cube equal to t because the derivative of x cube is x square. So x square dx will be dt by 2, dt by 3. But then you use this end. Okay. Next, 2 and 1 e raised to minus 1 upon x square dt. You can write this in this manner, e raised to minus 1 upon x into 1 upon x square dx. So here two options are there. You can also put 1 upon x as t or minus 1 upon x as t. So let's put minus 1 upon x is t. Derivative of minus 1 upon x is this. So 1 upon x square dx will be dt. Okay, right? And you have to change the limits and so on and so forth. Okay, don't forget to change the limits. Fine, so these were some hints. Okay, let me think of some more. So that you can practice. Yeah, integration 0 to 1 x upon x square plus 1. So put x square equal to t. Okay, you can also put x square plus 1 is equal to t because the derivative of x square and x square plus 1 will be same, that is 2x, which is present in the numerator. Okay, next hint, e 1 upon e dx x log x raised to 1 by 3. 1 upon e write in this format. Now put log x is equal to t. Okay, now guys see one more hint, this will be t raised to 1 by 3, it will go up, it will be t raised to minus 1 by 3. Also log e is 1 and log 1 upon e is log e raised to minus 1, which is minus 1 log e. Minus 1 will go over here, so answer is minus 1 over here. Okay, so these are the hints for this problem. Next one, 0 to pi by 3 cos x 3 plus 4 sin x dx. Put sin x is equal to t, or you can also put 3 plus 4 sin x is equal to 3. Any of the options. Okay, you can put any of the options over here, but then change the limits also. Okay, 0 to pi by 2 sin theta upon 1 plus cos theta d theta. Now you can put 1 plus cos theta as t, or you can also do this, multiply and divide with minus 0 to pi by 2. This is f dash theta because the derivative of cos is minus sign. That's why I multiplied and divided with minus. So this is minus 2 root f of x or 2 root f of theta. Okay, f of theta is this 1 plus cos theta. So I avoided method of substitution. After this you may solve. Okay, one last problem. 0 to 1 dx I'll apply indices. I'll take LCM. And then I'll send this up. Now you put e raised to x as t, that is the hint. And 1 upon 1 plus t square or 1 upon t square plus 1, the answer will be tan inverse t. So that's more what I have to say in this problem. Okay. That is the end of this particular session. Thank you.